Hello, welcome to Trigonometric Graphs. Following on from all the stuff we've done on sine rule and cosine rule, we're now going to look at the graphs of the functions and how we can use them to find different values of sine theta or sine x, and which values of x or theta would give you the same value. Would give you the same answer when you put it into the function. I'm sorry if you can hear drilling and stuff. There's a lot of construction going on, apparently right outside my window. So, yeah, I'm sorry if you can hear all of that. It's quite distracting. But, if we wait for them to stop, we'd be waiting forever. So here we are. Okay, so this is your first graph. You have the graph of y equals sin theta. So y is obviously on the y-axis, and we have changed our x-axis to theta now. So all of these values on that x-axis are values of theta. They are angles. And then depending what angle we've got, we put it into the function sin theta and we get our y value, okay? You can see that it's a wave. For sine, it starts at 0 and goes up, and then kind of completes the full wave by the time it gets to 360. So it kind of goes in a repeating pattern or a repeating section of 360 degrees. If you carried this on, it would come down and come back up and go and intersect the x-axis again at 720. And then again, it repeats in the negative direction as well. So it is just a repeat of the same wave over and over again in an interval of 360 degrees or negative 360 degrees, depending on which way you're going. From that, we can see if we put a value of 90 degrees into sin theta, then we get a value of 1. And we can see that happens in various different places along the graph. If we have a value of 450 degrees, then we also get 1. If we have a value of negative 270 degrees, we also get 1 when we put it into the function. And that is how we are going to use them. We're going to use kind of the symmetry and the repeated pattern of the graph to be able to work out which values of theta would give us the same value of y. But we will look at that in a second. So that is y equals sin theta. This is y equals, just a quick one. My teachers always used to say, and it's still how I remember it now, even though I'm not sure it makes an awful lot of sense, that sin is kind of like a backwards S. And that's how we know that it starts at 0 and it carries on and kind of repeats in that wave. I don't know if that helps. I honestly don't know if it makes any sense, but it's always stuck with me and it's always helped me remember which one's which. And then for cos, and this one makes even less sense, my teacher always used to say it's a cos bucket because it starts at 1 and it goes down straight away into like this dip. Again, I don't know if that makes sense, but it's stuck. I remember it, it's a long time after I was learning this for the first time, and that stuck, the cos bucket. Yeah, I don't know if it makes sense, I don't know if it helps, but there's something to remember. Cos starts at 1, so it's exactly the same shape and the same wave, and it's the same size as the sine graph, but it starts at 1. It's like almost like a transformation or a translation of the sine graph. It has just been shifted a little bit to the left or a big bit to the right, depending on which way you look at it. But it starts at 1, it goes down, it crosses the x-axis at 90, it comes back up after an interval of 180. So between 90 and 270 is 180, and then it goes back up to where we started again, and then we repeat the same shape, the same wave, the same size all the way across, and of course we continue it in the negative direction as well. Obviously, it should be a very smooth curve. This is hand-drawn, so it doesn't look particularly neat, but it follows that general pattern. And then last but not least, this one's my favourite because it just looks really cool. This is the graph y equals tan theta, which is, as you can see, different to the sine and the cos graphs. The sine and the cos graphs can only have values of can only have, what am I trying to say? The sine and the cos graph can only have solutions between 1 and -1. So when you put whatever value of theta you want into sine or cos, into the function sine or cos, then you only ever get values that go between 1 and -1, or those are kind of the limits of your function. Tan doesn't have a limit. You can see it continues up and it continues down in the positive and the negative direction. It never quite meets. These dotted lines are asymptotes, so it never quite crosses it. So it would just continue on getting closer and closer and closer to 90 degrees, but never actually getting there, which means that the tan doesn't have a defined solution when you have a value of theta that is 90. If you type that into your calculator, you would get one of those horrible math error. I don't have my calculator close by, but you would get one of those horrible maths error messages, which are just the worst, because it doesn't have it. It never quite. Yeah, it never quite crosses the 90 degree line. So it doesn't have an actual solution if you put it in your calculator. I just want to do it. I'm doing it on my phone. It just says error, because there is no defined solution for that. And you can see that happens every 180 degrees. So again, this graph starts negative, goes up in this lovely curved shape. It crosses 0, and it has asymptotes at -90 and 90. And then again, that repeats in intervals of 180. So again, we just repeat the same shape, kind of with an asymptote at 90 and 270, and then again and again, and once again in the negative direction. And it just repeats for as long, for as much as, it just continues for as long as you want it to. That's what I'm trying to say. So those are the 3 graphs. We are going to use, especially sine and cos, we're going to use the graphs to find different values of x for which sine of that value gives you a certain solution. So here we have our first question, typical kind of part A of an exam question. Just sketch the graph. You wouldn't get an awful lot of marks for this in an A-level exam, but it would, like I say, it would usually be like a part A of a question. I've got my axes ready just to make things a little bit quicker. Sketch the graph of y equals cos theta in the interval -360 to 360. So they will always give you an interval. They will always give you this part to tell you how big to draw the x-axis of your graph, because otherwise you could, keep going and going and going. And then that usually implies that, that determines how many solutions, like for the next question, you'll be asked how many different values of theta give you cos theta equals -0.5, for example. And how big the interval they've given you would depend on, would then determine how many solutions there would actually be. The bigger your graph, the more solutions. The smaller your graph, the less solutions. Okay, I hope that makes sense. Hopefully it will once you see it in action. So let's draw the graph. So like I say, cos is my cos bucket. Try and make your curve as smooth as you can. It has to go through 1 here and then down like this. It has to go all the way down to -1. Well, 180 -1, if we're doing the proper coordinate. Crosses back up, and then at 360 it reaches 1 again, so it's like that. Obviously that would carry on, but we are only interested in the graph between -360 and 360. And then same on the other side. So again, at -180, it is going to go down to -1. It is going to go back up through -270, and then we'll reach 1 again once we get to 360 degrees. And that is my graph in that particular interval. That is what the graph looks like. Again, try and make your curve as smooth as you can. Obviously, it doesn't have to be perfect. It is a sketch. but your kind of key points are where it reaches the limits. So where it reaches 1 and -1, you have to make it very clear that it is at -1 at 180 and it is at 1 at 360 and so on. Yeah, so that's that. Next question is sketch the graph of y equals sin x in the interval -180 and between -180 and 270. So do that first and then we'll come back to this part 2. So sine graph starts at 0 and goes up in my S shape. Yeah, so we're going up to 90. My axis is a bit bigger this time, so my graph's going to look a bit stretched out, but that's fine. Down to 180, and then it is going to get to 270 -1 like that, okay? And then same on the other side. We're going down and reaching -1 at -90, and then we are coming back up and crossing at -180. So there is the section of the graph that we are interested in. This second part is where we have to actually use the graph to find some other values of x for which sin x is equal to -0.5. So we know some piece of information. We know that sin -30 degrees gives us a value of -0.5. Use your graph to find 2 further values of x for which you get the same solution. So -30 degrees would be about here. Okay, let's just draw it on. There's -30. Let's kind of show me what I want it to. That gives us -0.5. So if I draw a straight line, we can see that, as suspected, because it says 2, it does cross the curve. That line at -0.5 does cross the curve in 2 other places, as well as the one that we've identified as being -30. We need to know what value is here, and we need to know what value is here. And because the graph repeats and is symmetrical, we can use that to work out exactly what those numbers are. So here, this is 30 away from the intercept there, okay? It's 30 less than where it is intercepting. Because it is symmetrical, here's the next intercept of the x-axis. So this would be 30 away from it. It's 30 more because we're going in the opposite direction. So it would be 30 more than -180. So the first value, this one, would be -180 plus 30, which is -150. So the first value would be at -150. The other value, again, the same symmetry. Here's our intercept at the x-axis. It would be 30 more than 180. So it would also give us the same solution when x is 180 plus 30, which is 210 degrees. And we can use the symmetry of the graph, and we can use that technique to find any other values of theta or x, whatever you want to call it, that would give us the same solution when we put them into the function sine x or sine theta or cos x or cos theta. And that's it. Those are the main things you need to know really about the graphs. The next video will look at how we can transform trigonometric graphs, because you will be expected to do that as well. But it's not, the rules to transforming a trig graph aren't any different to transforming any other type of graph, a quadratic or a cubic or an exponential graph. The rules are the same. We just need to look at applying them to a trigonometric graph as well as a quadratic, cubic, whatever type of graph. So that is what we will do next time. I hope this video is helpful. Thank you for watching it and have a lovely day.